In this video, we will continue the Spring Framework tutorial series by introducing you how to use database with the JDBC and Spring. JDBC is it comes from Java Database Connectivity. It's a Java-based database connectivity framework for manipulating databases, and we'll see how to do that in Spring. Especially, we want to use JdbcTemplate that automates many of the JDBC related code, so it eliminates all the boilerplate that would normally have to do. And for this project, which is customer JDBC, I have created two files. One is a customer. This represents a Java object to be persisted, to be saved to the database. It has a long ID, string first name, string last name. Could have more fields, but for now this is okay. And we have also a few different constructors. Then we have a schema.sql, which creates a table customer into a database, which has this corresponding fields: ID, first name, last name. So this table corresponds to the customer class. And now, first thing, before we start to do anything else, we will add a couple of dependencies to the maven file, pom.xml. And there are already some dependencies for the Spring project. This is a standard Spring maven project. And now add here first dependency, which is a Spring JDBC. It gives you a list of different options, and you would find the Spring JDBC from here. And add another one. We are going to use a database called H2 database. And this H2 database is so-called embedded database because it will be embedded in the memory of the running program. It will not be on any database server. It seems that this is not found, so we just add it manually, com.h2 database, and artifact ID h2, and the version that I was using is 1.4.185. You should check the latest version yourself. Okay, so now these two dependencies are done. We save the file, and next thing to do is to create the configuration file that will define the data source and define the JDBC template that we will use. So it's a normal configuration, Java configuration file. Naturally, you can do the same thing in XML, but this time I use this Java file. It's a configuration file, and we will also enable component scan. And the first thing to do in the configuration file is to define a bean that will serve as a data source. It's a normal SQL, Java SQL data source. And here you could create a MySQL data source or another database data source, but we are going to create embedded H2 database data source. So we just simply return new embedded database builder and set, okay, we need to import that. We need set type to embedded database type H2. So there are many different embedded databases. We use the H2, and also there are other methods, and we will use the before building we use add script. So we can add SQL script that will be executed when the database is created. So in this case we use the schema.xml SQL. You could also add other, for example, you could add another script to insert data to create a table. But for now this will be empty table, and we just build it and return it. Another bean that we are going to create here is JdbcTemplate. So JdbcTemplate automates many of the JDBC tasks, like opening connection to the database or handling exceptions, things like that. And JDBC template is implementing interface called JDBC operations, which is why we return that. We always play with interface types if possible. And this one takes data source as a parameter and returns new JDBC template that takes again the data source as parameter. And now, interesting thing here is that we don't manually connect these together. Spring can automatically figure out, okay, this method or this bean requires a data source and this bean provides a data source. So it can automatically connect them together. That's pretty cool about Spring. Okay, now that we have the data configured, the data source, the JDBC template, we can proceed to create an interface that will serve as the repository for our data. So create a customer repository. In Spring, the repository is kind of a data access object that handles the connection to a database table. So if you have more than one table, you probably have more than one repository. So there are a few methods here. One is to find one customer by ID. Another one is to save a customer, and it returns the same customer but including ID, because normally we don't know the ID. It will be generated when we add it to the database. We also have a method to find all customers, returns a list of customers, a method to update a customer, and a method to delete a customer. And well, list must be imported. It's Java util. So this returns a list of customers. So that's the repository. And now we can proceed to create a class that implements that repository. So call it, for example, customer repository implementation. Implemented interface, and you can see that everything is overridden. Of course, we need to write the code here. Now, in order to work with the database, we need to auto-wire that JDBC template. And as you remember, it implements JDBC operations interface. So we can just use that type and call it JDBC. And now when Spring will load the application, it will look here, configuration, okay, where is JDBC operations? It's here. It will call this method and return us a new JDBC template. And that will be injected. It will be auto-wired here. Another thing that we should add here is to, in order for this component to be found, we could add component. But a proper way to do it in Spring is to call it repository, which is kind of a sub annotation under component. So it's one of the special components. And repository represents a bean that can manage a database table. And then I've already prepared some SQL statements here as constants. So I'm just going to copy them. There are constants for inserting, updating, finding one, finding all, deleting one. So one for each of these methods that we override. And these use standard SQL syntax with placeholders that we will fill in later when we use this SQL statement. So let's see how to do it, how to use the JDBC template. It's very easy. So instead of opening connection and doing all the things manually that you normally do with JDBC, we simply call JDBC query for object. There are many query methods. This one is returning a single object. It takes a few arguments. It takes the SQL. So we are finding one. And it also takes the find one takes one parameter ID. So we get the ID there. And additionally, we need second parameter here, which is so-called row mapper that maps between the customer object and the database table. So we have to tell the Spring framework, the JDBC template, how we want the table columns to be mapped to this object's fields. So I'm just going to write here new customer row mapper, which I will create now. So this it could be in a different file, but I just write it here at the end as an inner class. Customer row mapper. And this customer row mapper is not just a normal class, it implements a row mapper that is based on customer. So row mapper interface has just one method. A map row. So this map row takes a result set and it takes a row number, and what we have to do here is that we need to return a customer that is created based on this result set. Right now we don't use the row number, but maybe some cases you might find it useful. But anyway, we just return a new customer object given result sets get long, and here we write the ID. So if you look at the customer constructor, we have this constructor here, long ID, first name, last name. So we use that one. Long ID, get string, first name, get string, last name. Okay, so now whenever this map row is called, it will create a new customer based on this result set. Now we don't call this manually. It will be called by the JDBC template whenever we query for object, or later here where we find all objects. So, but basically this is it, just one line of code. We can make a simple query to the database. I'm doing save later because it's a bit more complex. Let's see how we can do this find all. It's also quite similar to this find one. Instead of query for object that we used here, this one returns a JDBC query, just a query. SQL find all, this is our constant for finding all, and new customer row mapper. Similar row mapper is used here, and there are no parameters because this one has no question marks. Update, also quite simple. Instead of a query, we call JDBC update. So there is update that is used both for update, delete, and also insert. So this one is SQL update, and now we don't need row mapper because we return just integer. So no need for row mapper, but we need to have 1, 2, 3. So first name, last name, ID. 3 parameters. So we get customer first name, customer last name, customer ID. Remember, the order is important. You must have the same order that is in the SQL. And finally, delete. It's also update. SQL delete 1. This was our constant. And it takes just one parameter, get ID. And one will be deleted, and it will return the number, how many rows were affected. And now, okay, these are quite trivial cases, just one statement operations. But saving is more difficult because we must return a customer, basically the same customer than the input, but this one needs the ID included. And how to get the ID, well, that's the complex part, but it's not too complex. We need something called key holder that will hold the key and return it to us when we do this, when we execute the statement. So let's see, it's a new generated key holder. Import. And then, well, this seems a bit complex, but actually it's not that complex. We performed another JDBC update, so we modify something. And here, instead of just calling query or just adding the SQL, we create a new prepared statement. Actually, we create a new anonymous inner class called prepared statement creator. And this anonymous inner class, prepared statement creator, has one. I think we need to import that. Okay, now it's a bit messy, but this prepared statement creator interface has this method that would return a prepared statement. It takes connection as an argument, and we just basically create the prepared statement here. Sorry, not new, but we ask it from the connection. We ask connection to create a prepared statement. And this one takes the SQL insert, so we are inserting the SQL. And we also add another parameter, which I will explain you after I type it. Just string array, and it has only one element ID. So the purpose of this string array is to tell the prepared statement string, not string, but string. We tell to the prepared statement that when it's executed, it should return the ID as a result. And where we put the result? Well, it will be put here in the key holder, actually holder. So we ask it to get the ID as a result and put it here. It's a bit complex, but this is how it works. And then we need to, insert statement has two values here, two question marks, so we need to set them. Set string, the first one is customer first name. Second one is customer last name. And one thing is that this cannot be accessed now, because this one here is not final. So whenever you want to use some variable inside anonymous inner class, it must be declared final. And then finally return PS. Now that one is done. And one thing to do is, after executing this update, we get the number of affected rows. And if the rows is 1, then it means it succeeded. And we can update this customer. Set the ID to key holders key. So we get the key from the key holder, which happens to be the ID. And then we cast it to long because it's object by default, and return customer. So we return the same customer but with new ID. Otherwise return null if something fails. That's it for the implementation. So the insert was a bit more complex. If you don't need the ID, if you, for example, want to just return true or false, then you don't need to do this stuff. You can just do a normal update as you do with, for example, this one, same way. But now let's write a simple test application that will actually use that repository. Normally you would of course write another bean or perhaps MVC, like a controller that would use that repository, but here I'm just writing standalone application to keep it simple. So we use the annotation config application context to load the configuration file, which is the config.class, and then we get the customer repository from the context as a bean. I'm using the interface type here. And now that we have the repository, we can start creating customers and adding them there to the database. So say we have a customer C1. This would be John Doe. Let's create another one too. Jane Doe. And then we can add them to the repository. Save C1, C2. Now remember that these save operations returns modified version of C1 and C2 because it adds the ID number to them. The ID number is needed when we want to modify them, for example, or delete them. So now we save the new versions of the C1, C2 and try to print out everything. So we have a little for each loop here. Let's call it T, like temp, and repo find all. And now what we can do is just print out T get first name and T get last name. Perfect. Let's see if it works. So we can try to run it as a normal Java application. We get John Doe, Jane Doe. So everything seems to be fine. Now let's try to modify, say C2 set first name. Let's Jane decides to change first name to Janet. And then we can modify, we can ask the repository to update C2, and we can print out the same stuff again. Let's see. Okay, now we have John Doe and Janet Doe. Perfect. And let's try one more thing. Let's try to delete one. So we can, for example, delete John. So repo delete C1 and print out again. And we get Janet Doe as the last one. So first print out, second print out, last print out. So that's how you use JDBC template on Spring Framework. Next we will discuss how to use Java Persistence API, which is even more powerful. Thanks for watching.